On May 21st, 2026, the National Oceanic and Atmospheric Administration stood in front of the American public and told them the upcoming hurricane season would likely be below normal. 8 to 14 named storms, 3 to 6 hurricanes, 1 to 3 major hurricanes. A 55% chance that this season will be quieter than average. And across the Gulf Coast, from Brownsville to Key West, 50 million people heard that number and exhaled. Here is what NOAA did not put in the press release. As of May 11th, 2026, sea surface temperatures in the Gulf of Mexico are tied with 2024 as the warmest ever recorded for that date. 1 full degree Celsius above the 30-year average. The Gulf has been warming at twice the rate of the global ocean since 1970. Since 2012, the warming rate during peak hurricane season, August through October, has accelerated by a factor of 16 compared to the long-term trend since 1850. The loop current, a deep river of Caribbean heat that acts as a fuel line for rapidly intensifying hurricanes, shed a warm core ring in February and is now extending northward again, reloading the central Gulf with deep, warm water just in time for peak season. And a peer-reviewed study in Communications, Earth and Environment found that rapid intensification of hurricanes in the Gulf of Mexico is 50% more likely during marine heat waves. The Gulf of Mexico is in a marine heat wave right now. It has been in one, off and on, for the better part of 3 years. So here is the question that should be at the center of every conversation about the 2026 hurricane season. And it is a question no seasonal forecast is designed to answer. If El Niño suppresses the number of storms but record-setting ocean heat supercharges the ones that do form, are Americans safer this year, or are they standing in front of a smaller number of larger guns? I am going to walk you through exactly what the data shows. And I need to warn you up front, the answer is not the one most people want to hear. Before we go any further, if you enjoy what we do here at Ashfall Debrief, make sure to hit like and subscribe so you do not miss any of our nightly debriefs. Also, drop a comment and tell me where you are watching from. Now, let us get into it. Part 1. The forecast that made everyone relax. Let me be precise about what NOAA actually said on May 21st, because the details matter more than the headline. The agency issued its 2026 Atlantic hurricane season outlook with a 55% probability of below normal activity, a 35% probability of near normal activity, and a 10% probability of above normal activity. The predicted range of 8 to 14 named storms compares to a modern average of 14. 3 to 6 hurricanes compares to an average of 7. 1 to 3 major hurricanes compares to an average of 3. By every standard metric in the seasonal forecasting toolkit, this is a call for a quiet year. The driving force behind that call is one word: El Niño. El Niño is a natural climate pattern where ocean water in the central and eastern equatorial Pacific warms above average, shifting atmospheric circulation patterns across the entire globe. The Climate Prediction Center models, along with Columbia University's International Research Institute for Climate and Society, are tracking a developing warm anomaly in the Pacific that is expected to intensify into a moderate or strong El Niño by the height of hurricane season in August and September. Some model runs suggest a 15% chance it reaches what meteorologists call a super El Niño, with Pacific sea surface temperature anomalies exceeding 2 degrees Celsius above the long-term average. The last super El Niño occurred in 2015 through 2016. Before that, 1997 through 98. Both events dramatically suppressed Atlantic hurricane activity. When El Niño shows up during hurricane season, it rewires the atmospheric plumbing over the Atlantic Warm water rising in the equatorial Pacific shifts the subtropical jet stream, which amplifies upper-level westerly winds across the tropical Atlantic and the Gulf of Mexico. Those winds create vertical wind shear. Wind shear is the change in wind speed and direction between the ocean surface and around 40,000 feet. It is the single greatest enemy of a developing tropical cyclone. Shear tilts the storm's core, so the low-level circulation gets separated from the upper-level outflow. It tears apart the organized thunderstorm structure, disrupts the warm core, and prevents the self-reinforcing feedback loop between the ocean and the atmosphere that a hurricane needs to grow. Put it simply, El Niño turns the Atlantic into hostile airspace for hurricanes. Storms that try to form get shredded before they can organize. And that is not speculation. The historical record supports it conclusively. 1997 was a strong El Niño year. 7 named storms, 3 hurricanes, 1 major. 2015 had a strong El Niño. 11 named storms, 4 hurricanes, 2 major. None made landfall in the United States. The statistical relationship between El Niño and reduced Atlantic hurricane counts is one of the most robust signals in seasonal climate forecasting. NOAA National Weather Service Director Ken Graham said it in the press release. Although El Niño's impact in the Atlantic basin can often suppress hurricane development, there is still uncertainty in how each season will unfold. That is why it is essential to review your hurricane preparedness plan now. It only takes 1 storm to make for a very bad season. Colorado State University released its forecast in April. 13 named storms, 6 hurricanes, 2 major. AccuWeather came in slightly higher at 11 to 16 named storms, 4 to 7 hurricanes, 2 to 4 major. Every credible forecasting center is calling for below average or near average activity, and every single one of them buried the same caveat somewhere in the report. It only takes 1. That phrase has become the standard closing line of every hurricane season outlook. It sounds like responsible due diligence, but I want you to consider the possibility that it is not a disclaimer at all. It is the most important sentence in the entire forecast, and the reason it is the most important sentence has everything to do with what is happening beneath the surface of the Gulf of Mexico right now. And let me add one more piece of context before we move on, because I think it is essential. The 2026 hurricane season is beginning in a specific historical context that amplifies the complacency risk. The United States has not been hit by a hurricane since 2024. Hurricane Helene struck the Florida Panhandle and Hurricane Milton hit near Sarasota. Both caused catastrophic damage. But in 2025, no hurricane made US landfall. For the first time in a decade, the country got a pass. After 2 devastating years in 2023 and 2024, with multiple billion-dollar tropical events, the 2025 season felt like a reprieve. Human psychology does not handle probability well. It handles narrative. And the narrative that many Americans internalized from 2025 is the hurricanes went away. That narrative is now being reinforced by NOAA's below normal forecast. The public is being told, in effect, that the break will continue. And while that may be true for the total storm count, it is emphatically not true for the danger posed by any individual storm that manages to form in the Gulf. The 2025 reprieve was not a forecast success. It was a steering pattern success. The storms formed. They were among the strongest in recorded history. They just went elsewhere. And the public, understandably, does not distinguish between fewer dangerous storms and dangerous storms that went somewhere else. The result is the same from the perspective of someone standing on a Florida beach. Nothing happened to me last year. That is exactly where we are going next, into the ocean itself, because the ocean does not know about the reprieve, and it has been building energy the entire time. Part 2. The ocean that will not cool down. I need you to set aside the storm count for a moment and focus on where the energy for hurricanes actually comes from, because the number of storms that form in a given season tells you almost nothing about how dangerous that season will be for the people living along the coast. What determines the danger is the energy available to the storms that do form, and that energy is stored in the ocean. A hurricane is, at its core, a heat engine. It takes thermal energy from the ocean and converts it into kinetic energy, which is wind. The warmer the ocean, the more energy is available. The deeper the warm water extends below the surface, the longer the storm can draw on that energy without encountering the cold water that acts as a natural break. Everything about a hurricane's potential comes back to the ocean. So let me walk you through what the ocean in the Gulf of Mexico looks like in late May 2026. Sea surface temperature data compiled by Kim Wood at the University of Arizona shows that as of May 11th, Gulf sea surface temperatures were tied with May 11th, 2024 as the warmest ever recorded for that date. That puts the Gulf at more than 1 degree Celsius, roughly 1.8 degrees Fahrenheit, above the 1991 to 2020 average for mid-May. 1 degree might not sound like much. Stay with me, because in hurricane physics, it is enormous. A study published in the American Meteorological Society's Journal of Climate analyzed nearly 193,000 temperature profiles from the Gulf of Mexico, collected between 1950 and 2020. The researchers, a team from the National Centers for Environmental Information and the Northern Gulf Institute, found that Gulf sea surface temperatures increased approximately 1 degree Celsius between 1970 and 2020. That equates to a warming rate of 0.19 degrees Celsius per decade, roughly twice the global ocean average. But that long-term average masks an acceleration that has been underway since 2012. Jeff Masters and Bob Henson at Yale Climate Connections published an analysis on May 19th that broke this down with striking precision. During the peak 3 months of hurricane season, August through October, the departure of Gulf sea surface temperatures from the historical average has been rising at 0.32 degrees Celsius per decade since 2012. That is 16 times faster than the long-term trend since 1850. Let me say that again. During the exact months when hurricanes are most active, the Gulf of Mexico has been warming at a rate 16 times higher than the historical baseline. This is not a gradual drift. This is a thermal escalation, and it is not just the surface. Part 3. The heat you cannot see. Ocean heat content is a measurement that goes beyond the surface temperature. It captures the total thermal energy stored in the water column, from the surface down through the upper ocean layers. When a hurricane moves across the ocean, its powerful winds churn up water from below the surface. If the warm layer is shallow, 10 or 20 meters deep, the hurricane quickly dredges up cold water. That cold water cuts off the energy supply, and the storm weakens. This is the ocean's natural thermostat, its built-in brake on hurricane intensity. But when warm water extends 100 meters or deeper below the surface, the hurricane's churning just brings up more warm water. There is no cold break. The storm feeds and feeds, pulling in moisture and heat from a seemingly bottomless reservoir, and the feedback loop between ocean and atmosphere runs unchecked. That is when rapid intensification happens. Brian McNoldy at the University of Miami has been tracking Gulf Ocean heat content for over a decade. His charts, which are publicly available and updated regularly, show a pattern that should concern anyone living within driving distance of the coast. Since 2013, the Gulf's ocean heat content has been climbing in a stair-step pattern. Not a smooth rise, a staircase. Each step up represents a new baseline. Each peak season starts from a higher thermal floor than the one before it. The envelope of available energy keeps shifting upward. As of May 2026, ocean heat content in the Gulf is at near record levels. Not record-breaking, not yet, but within the margin of the highest values ever measured. And hurricane season has not even started. The ocean will continue warming through June, July, and August, typically peaking in September. NOAA's climate forecast system model projects that Gulf sea surface temperatures during peak season will fall short of the absolute records set in 2023 through 2025. But even if they fall short, they will still be well above the levels that historically fueled Category 4 and 5 hurricanes. And here is where the science gets genuinely unsettling. There is a growing body of evidence that the Gulf's warming is not just a gradual trend. It may involve a regime shift, a permanent step change in the thermal baseline. The Yale Climate Connections analysis published on May 19 cited a phenomenon that oceanographers have been studying for several years. After the 2015 through 2016 Super El Niño, wintertime sea surface temperatures in the Gulf of Mexico experienced an abrupt upward shift. Over the 10 winters from 2016-17 through 2025-26, Gulf winter sea surface temperatures averaged 0.8 degrees Celsius above normal. During the previous 10 winters, 2006-07 through 2015-16, they were only 0.2 degrees above normal. That is a four-fold increase in the winter temperature anomaly concentrated in a single step, rather than a gradual trend. Why does the winter temperature matter? Because the winter baseline sets the starting point for the following hurricane season. If the ocean starts warmer in January, it reaches dangerous thresholds earlier in the summer. 83-degree water in late July instead of mid-August. 86-degree water in August instead of September. The entire seasonal clock shifts forward, expanding the window of vulnerability. Researchers have speculated that this regime shift may have been triggered by changes in the loop current's behavior following the Super El Niño. If the current El Niño, the one developing in 2026, reaches Super El Niño status, it could potentially trigger another regime shift, ratcheting the Gulf's thermal baseline even higher. I want to be careful not to overstate the certainty here. Regime shifts in ocean systems are complex and not fully understood, but the observational data is clear. Something changed in the Gulf around 2016. The winter temperatures jumped, the summer peaks followed, and the remarkable number of rapidly intensifying hurricanes observed in the Gulf beginning in 2017, Harvey, Irma, Michael, Laura, Ida, Helene, Milton, may not be a coincidence. They may be a consequence. Now I need to talk about the mechanism that concentrates that heat into specific geographic corridors. Because the Gulf is not a uniform body of water. It has currents, and one current in particular acts as a delivery system for concentrated, deep oceanic energy that no storm can exhaust. Part 4. The loop current and why it changes everything. The loop current is a ribbon of warm Caribbean water that enters the Gulf of Mexico through the Yucatan Channel, the strait between Cuba and the Yucatan Peninsula. It flows northward into the central and eastern Gulf, then bends sharply to the southeast, passing just south of the Florida Keys, where it becomes the Florida Current, and then continues northward along the U.S. East Coast as the Gulf Stream. It moves at about 1.8 miles per hour, which is roughly 0.8 meters per second, making it one of the fastest flowing currents in the Atlantic Ocean. And it carries heat, not surface heat, deep heat, the kind that extends 200 meters or more below the surface. Periodically, the loop current sheds what is called a warm core eddy or a loop current ring. This is a massive rotating body of deep, warm water that detaches from the main current and drifts westward into the Gulf. These eddies can be 150 to 300 kilometers across and contain enough thermal energy to sustain rapid intensification in any tropical cyclone that crosses their path. In February 2026, the loop current shed one of these warm core rings. Since then, it has been in a regrowth phase, extending northward again. The Yale Climate Connections analysis noted that this regrowth mode favors the release of another loop current eddy during peak hurricane season, which would further increase the odds of rapid intensification for any storm that enters the Gulf. This is not abstract. This is exactly what happened in 2024. Twice, Hurricane Helene formed in the Western Caribbean in late September 2024. It was initially a broad, disorganized tropical system that forecasters expected to become a moderate hurricane. As it moved northward into the eastern Gulf of Mexico, it encountered the loop current. The deep, warm water extended more than 100 meters below the surface. Helene's intensification curve went vertical. It went from a Category 1 hurricane to a major Category 4 in roughly 36 hours, with sustained winds reaching 140 miles per hour at landfall in the Florida Panhandle's Big Bend region. But the wind was not the story. The story was the water. Helene was an unusually large storm, and its wind field pushed a massive storm surge into the Big Bend coast. Then, as it moved inland, the storm's remnants carried an extraordinary volume of moisture northward. Over the Appalachian Mountains of western North Carolina, eastern Tennessee, and southwestern Virginia, the rainfall totals in parts of western North Carolina exceeded 30 inches in 48 hours. Rivers that had never been documented at flood stage reached levels that geologists said corresponded to a 1,000-year return period. Entire communities in the mountains were inundated. Roads washed away, bridges collapsed, cell towers went dark. More than 230 people died. The majority of deaths occurred not on the coast, but in the mountains, hundreds of miles from where the storm made landfall. In Buncombe County, North Carolina, home to Ashfall, entire neighborhoods along the Shenandoah River were swept away. The French Broad River reached levels not seen in 1,000 years. Chimney Rock, a tourist town in the Blue Ridge foothills, was effectively destroyed. Mudslides buried homes. Roads that had been carved into mountain passes for a century were peeled off the slopes like wallpaper. No seasonal forecast, no hurricane intensity model, no storm surge map anticipated that the deadliest aspect of Helene would be inland flooding in Appalachia. No evacuation order was issued for western North Carolina because the mountains are not on any hurricane evacuation map. The people who died were not in the cone of uncertainty. They were not in a flood zone. Many of them had never experienced a tropical system of any kind. That is a secondary effect, the kind of cascading, non-obvious, geographically displaced consequence that the seasonal outlook does not and cannot predict. And it is a perfect illustration of why the total storm count is such a misleading metric for public safety. Helene was one storm. Its cone of direct impact covered a few hundred miles of Florida coastline. Its actual zone of catastrophic damage extended from the Florida Panhandle to the mountains of Virginia, a distance of more than 500 miles. One storm, hundreds of miles of destruction, that no forecast model anticipated. And then, less than 2 weeks later, on October 5th, Hurricane Milton formed in the western Gulf of Mexico. Milton crossed the same anomalously warm waters and underwent the most explosive intensification event of the modern satellite era. It grew from a Category 1 hurricane with 80 miles per hour winds to a Category 5 with 180 miles per hour winds in approximately 24 hours. That is 100 miles per hour of intensification in a single day, more than twice the threshold for what meteorologists now classify as extreme rapid intensification. Let me put that in perspective. When Milton was a Category 1 hurricane at 10 in the morning on October 7th, residents along the Florida Gulf Coast were being advised to prepare. By 10 that evening, it was a Category 5. The entire decision-making window for evacuation compressed into 12 hours. 12 hours to decide whether 3 million people in the Tampa Bay area needed to leave. Milton's peak sustained winds of 180 miles per hour made it the strongest hurricane ever recorded in the Gulf of Mexico. It weakened before making landfall near Siesta Key, Florida, as a Category 3 on October 9th, but it still produced devastating storm surge, EF3 tornadoes, and catastrophic flooding across central Florida. Milton drew its power from Gulf waters that were 4 degrees Fahrenheit above normal for early October. As of late, May 2026, the Gulf is at the same temperature or warmer than it was at the equivalent point in 2024, the year that produced both Helene and Milton. That comparison is not incidental. It is the foundation of the threat assessment for the entire 2026 season. Part 5. Rapid intensification rebuilt as a physical process. I want to take a moment to explain exactly what rapid intensification is, because the term gets thrown around a lot in hurricane coverage, and I think most people do not fully understand the mechanism or why it is so dangerous. The formal definition is an increase in maximum sustained winds of at least 35 miles per hour, which is 56 kilometers per hour, within a 24-hour period. Alternatively, a central pressure drop of at least 42 millibars in the same time frame. When a storm exceeds that threshold by a significant margin, the newer term is extreme rapid intensification. Here is what is happening inside the storm. A hurricane's core is a column of warm, moist air rising over the ocean. As that air rises, water vapor condenses into cloud and rain, releasing the latent heat that was absorbed when the water originally evaporated. That released heat warms the air column, making it lighter, which causes it to rise even faster. The faster it rises, the more the surface pressure drops. The lower the surface pressure, the faster air rushes inward at the surface to replace the rising air. That inrushing surface air picks up more moisture and heat from the warm ocean, carries it upward, and the cycle amplifies. In normal conditions, this feedback loop runs at a manageable pace. The storm strengthens gradually over days. Forecasters can track it. Emergency managers can issue warnings. Evacuations can be ordered. But when the ocean is extremely warm and the warm layer extends deep below the surface, and when the atmospheric environment has low wind shear, the feedback loop runs away. The thermal energy available at the surface and below it is so fast that the storm's intensification curve goes nearly vertical. A system that was a disorganized tropical storm in the morning is a major hurricane by nightfall. A 2023 study published in Scientific Reports found that Atlantic tropical cyclones were 29% more likely to undergo rapid intensification in the period from 2001 to 2020 compared to 1971 to 1990. The trend is not subtle. It is accelerating, and research on the intensity-temperature relationship quantifies the connection. Hurricane potential intensity, the theoretical maximum wind speed a storm can achieve given the available ocean energy, increases by roughly 5 to 7% for each 1 degree Celsius rise in sea surface temperature. Studies have shown that a 1 degree Fahrenheit increase in peak season sea surface temperatures is associated with a 40% increase in hurricane activity and frequency. When sea surface temperatures climb from 80 degrees to 85 degrees Fahrenheit, hurricane rainfall increases by a factor of 5. Once sea surface temperatures exceed 83 or 84 degrees Fahrenheit and wind shear is light, fully formed hurricanes frequently undergo rapid intensification. The Gulf of Mexico routinely exceeds those temperatures by July. Increasingly, it reaches them in June. The recent history of Gulf hurricanes reads like a catalogue of rapid intensification events, and the pace has been accelerating. Hurricane Harvey in August 2017 crossed the Gulf from the Yucatan Channel and rapidly intensified from a tropical storm to a Category 4 hurricane in 48 hours before making landfall near Rockport, Texas. But Harvey's deadliest feature was not its wind, it was the rainfall. The storm stalled over the Houston metropolitan area for 4 days, dumping more than 60 inches of rain in some locations. The total economic damage exceeded $125 billion. Over 100 people died, most of them from drowning. Hurricane Laura in August 2020 rapidly intensified in the Gulf from a Category 1 to a Category 4 in 24 hours. It made landfall near Cameron, Louisiana, with 150-mile-per-hour winds and a storm surge that reached 17 feet. The town of Cameron was essentially erased. Hurricane Ida in August 2021 entered the Gulf as a tropical storm and rapidly intensified to a Category 4 with 150-mile-per-hour winds in roughly 36 hours. It hit Port Fourchon, Louisiana, on the 16th anniversary of Katrina. The entire city of New Orleans lost power. The grid was down for weeks in some parishes, and Ida's remnants carried catastrophic flooding into the northeastern United States, killing 43 people in New Jersey and New York, places that had only a few hours of warning before the water arrived. Every single one of these storms drew its power from anomalously warm Gulf waters. Every single one rapidly intensified over the same general area, the central and eastern Gulf, where the loop current and its eddies concentrate deep heat. And every single one caught at least some portion of the affected population off guard because the intensification was faster than the models predicted. Now here is the critical point. The Gulf water during Harvey in 2017 was considered exceptionally warm. During Ida in 2021, it was warmer. During Helene and Milton in 2024, warmer still. And right now, in May 2026, the Gulf is running at temperatures equal to or exceeding May 2024 levels. The trend line is not ambiguous. The fuel available for rapid intensification is increasing. The storms are responding to that fuel. And the forecasting models, while improving, still cannot reliably predict when a storm will undergo rapid intensification until it is already happening. The National Hurricane Center's official intensity forecast errors for rapid intensification events remain significantly larger than for storms that intensify gradually. This is one of the most active areas of research in hurricane science, and progress is being made. But the gap between forecast and reality during rapid intensification events is still measured in tens of miles per hour of wind speed, which translates to the difference between an evacuate recommendation and a shelter-in-place emergency. And that connects directly to the danger of the current situation. Because in a strong El Niño year, the Atlantic is generally sheared and hostile. Storms cannot form easily, but the Gulf of Mexico's water temperature does not care about El Niño. The thermal energy is there regardless. It is waiting. And if a tropical disturbance finds a window, even a brief one, where the shear temporarily relaxes over the Gulf, the energy available for rapid intensification is at or near the highest levels ever recorded. That is the mechanism that seasonal forecasts cannot capture. And that brings us to the part of the historical record that makes the below-normal forecast so much more complicated than it appears. Part 6. The quiet years that killed. I want you to hold two numbers in your mind, 7 and 27.3 billion. The first number is the total count of named storms during the 1992 Atlantic hurricane season. 7 named storms, 4 hurricanes, 1 major. By any standard, it was a quiet year. El Niño was present in the Pacific. Wind shear was elevated across the Atlantic. The tropical wave activity coming off Africa was weak. Through mid-August, the season had produced so little activity that on August 16th, the National Hurricane Center held a press briefing specifically to discuss the lack of a hurricane season. Former NHC Director Max Mayfield later recalled that moment at the 2012 National Hurricane Conference. On August 16th, he said, "We discussed with the media the lack of a hurricane season." On August 16th, the same day as that briefing, a tropical wave that would become Hurricane Andrew was already in the Atlantic. 8 days later, Andrew made landfall in Homestead, Florida, as a Category 5 hurricane, sustained winds of 165 miles per hour, central pressure of 922 millibars. Andrew destroyed 63,000 homes. It damaged more than 100,000 others. 65 people died. The total damage was $27.3 billion 1992 dollars. Adjusted to today's values, accounting for inflation and the massive increase in coastal development since then, the equivalent impact would exceed $70 billion. One storm in a season of 7, in a year when El Niño was supposed to keep things quiet. And Andrew was not an isolated case. The historical record is littered with devastating hurricanes during quiet seasons. 1983, another strong El Niño year. Only 4 named storms formed in the entire Atlantic basin. Some recent seasons have produced that many in a single month. But one of those 4 was Hurricane Alicia, a Category 3 that hit Houston and Galveston in mid-August, with winds of 115 miles per hour. 21 people died. Damage reached $3 billion, and the seasonal count was 4. 1965, Hurricane Betsy, a relatively quiet stretch of the season. Betsy crossed the Bahamas, hit the Florida Keys, then crossed the Gulf and struck Louisiana. 10-foot storm surge in New Orleans. 75 people dead. It was the first hurricane in American history to cause more than $1 billion in damage. At the time, it was considered almost unimaginably destructive. The pattern repeats. El Niño suppresses the total count. The storms that break through the shear have already demonstrated unusual resilience. And when those survivors find warm water, they are disproportionately dangerous. Because a storm that can maintain itself through hostile conditions is, by definition, a storm with an unusually robust circulation. Give that storm fuel, and it does not just intensify, it explodes. Ken Graham, the NWS director, named Betsy, Alicia, and Andrew explicitly in his 2026 hurricane forecast comments. He was not being academic. He was trying to signal something that the headline below normal does not communicate. below normal seasons produce catastrophic hurricanes. They always have. And the ocean they are forming over in 2026 is warmer than it was during any of those historical parallels. But I want to go one step further, because the quiet season deadly storm pattern is only half the historical lesson. The other half comes from seasons where forecasters got the count approximately right, but missed the intensity entirely. And for that, I need to talk about 2005. Part 7, the season that rewrote everything. The 2005 Atlantic hurricane season produced 28 named storms, 15 hurricanes, and 7 major hurricanes. 4 of those reached Category 5. Emily, Katrina, Rita, Wilma. It remains the most active and most destructive hurricane season in recorded history. But here is the part that most people have forgotten. The early season was relatively quiet. Through July of 2005, the Atlantic had produced 6 named storms. That is slightly above average pace, but nothing alarming. Arlene, Brett, Cindy, Dennis, Emily, and Franklin. Dennis was the notable one, a Category 4 that hit Cuba and then the Florida Panhandle. But the season did not become the monster we remember until August. Katrina formed on August 23rd. It crossed southern Florida as a modest Category 1, entered the Gulf of Mexico, and found the loop current. What happened next changed American emergency management forever. Katrina did not just intensify. It underwent explosive, rapid intensification. In 48 hours, it went from a Category 1 hurricane to a Category 5 with sustained winds of 175 miles per hour and a central pressure of 902 millibars. The fuel for that intensification came from the deep warm water of the loop current, which extended more than 150 meters below the surface along Katrina's track. The storm's winds could not churn up cold water because there was no cold water to find. Katrina made landfall near the Louisiana-Mississippi border on August 29th as a high-end Category 3 with winds of 125 miles per hour. It had weakened slightly from its Category 5 peak, but its wind field was enormous, stretching hurricane-force winds across an area more than 200 miles wide. The storm surge along the Mississippi coast reached 28 feet. In some places, it penetrated 12 miles inland. The surge overtopped the levees protecting New Orleans, which were designed for a Category 3 but were overwhelmed by the sheer volume of water being pushed against them. 80% of the city flooded. Some neighborhoods were under 15 feet of water. The death toll was 1833. The damage was $125 billion. It was, and remains, the costliest natural disaster in American history. Entire communities along the Mississippi coast simply ceased to exist. Waveland, Bay St. Louis, Pass Christian, the tax base vanished. The population scattered. Some never returned. And the mechanism that transformed Katrina from a moderate Florida hurricane into a civilization-level catastrophe was the deep warm water of the loop current in the Gulf of Mexico. The same loop current that is extending northward right now. The same deep warm water that is building in the Gulf right now, in a warmer ocean than Katrina ever saw. 3 weeks after Katrina, Hurricane Rita formed in the western Atlantic, crossed the Florida Keys, and entered the Gulf. Rita also passed over the loop current and rapidly intensified to Category 5 with 180 mile-per-hour winds, briefly becoming the 4th most intense Atlantic hurricane on record. It weakened before landfall but still hit the Texas-Louisiana border as a Category 3. But the most devastating aspect of Rita was not the storm itself. It was the evacuation. Houston, still reeling from Katrina coverage, was under voluntary evacuation orders. 3.5 million people tried to leave simultaneously. The highways became parking lots. Contraflow lanes were activated too late. Traffic moved at walking speed. Gas stations ran dry. The temperature was over 100 degrees. Over 100 people died during the evacuation itself, many from heat exposure, dehydration, and carbon monoxide poisoning in vehicles idling for 12 or more hours on gridlocked highways. A bus carrying nursing home evacuees caught fire near Dallas, killing 23 people. More people died fleeing Rita than died from the storm's direct impact in Texas. I tell this story in detail because it demonstrates something critical about the 2026 risk. The danger of a Gulf hurricane is not limited to wind and surge. It includes the human system's response to the threat. When rapid intensification compresses the timeline, evacuation decisions become life and death gambles. Leave too early and you might evacuate for a storm that turns. Leave too late and you are trapped on a highway with no shelter. Do not leave at all and you are betting your life that the storm weakens before landfall. Then Wilma in October, the most intense Atlantic hurricane ever recorded at the time. Pressure of 882 millibars, 185-mile-per-hour winds. Wilma hit Cancun, then crossed the Gulf and made landfall in southwestern Florida as a Category 3. I tell this story not because 2026 is likely to repeat 2005. The El Niño suppression makes a 28-storm season essentially impossible. I tell it because 2005 demonstrated what the Gulf of Mexico is capable of when its thermal energy is unleashed. And the ocean heat available in 2026, particularly the deep heat content and the loop current configuration, is comparable to or greater than what was available in 2005. The difference is that in 2005, there was no El Niño to limit the number of storms. In 2026, there will be, which means fewer storms will form, but the ones that find the energy will find more of it than Katrina did, more than Rita did, more than any storm in the past 2 decades, because the ocean has been accumulating heat at an accelerating rate for the entire intervening period. The 2005 season was quantity and quality. The 2026 season, if a storm breaks through, could be quality unlike anything the modern Gulf Coast has experienced. Part 8. What 2025 proved beyond argument. The 2025 Atlantic hurricane season deserves its own section in this debrief because it is the most relevant precedent for what could happen in 2026. And almost nobody is drawing the connection. 2025 ended with 13 named storms, 5 hurricanes, and 4 major hurricanes. Those numbers are close to average. The season's accumulated cyclone energy, or ACE, which accounts for both the number and intensity of storms over their lifetimes, came in at 9% above the 30-year average, classifying it as slightly above normal. But the numbers hide what actually happened. 3 of 2025's 13 named storms reached Category 5 intensity. Erin in August, Humberto in September, Melissa in October. 23% of all named storms that year hit the top of the Saffir-Simpson scale. The historical rate for Category 5 is 3%. 2025 was nearly 8 times higher. It made 2025 only the second season in recorded history to produce more than 2 Category 5 hurricanes. The only season with more was 2005, which had 4. And the back-to-back years of 2024 and 2025 mark only the second time the Atlantic has seen consecutive years with multiple Category 5s. The only previous occurrence was 1932 and 33. The details of these storms are instructive. Hurricane Erin rapidly intensified from 75 miles per hour to 160 miles per hour in 24 hours, one of the fastest intensification periods on record. Its pressure dropped 83 millibars in that same window, tied for the third fastest pressure drop ever observed in the Atlantic Basin. Hurricane Humberto jumped from a 65-mile-per-hour tropical storm to a 145-mile-per-hour major hurricane in 24 hours, peaking at 160. It was the first time since 1935 that the first 3 hurricanes of a season were all major. Hurricane Melissa was the most catastrophic. It underwent a wind increase of 115 miles per hour over a 72-hour period. It made landfall in southwestern Jamaica on October 28th as the strongest Atlantic hurricane landfall ever recorded. 185 miles per hour, central pressure of 892 millibars. Jamaica sustained $6 to $7 billion in damage. Entire communities were flattened. The agricultural sector was decimated. The WMO retired the name Melissa in March 2026. CSU research scientist Levi Silvers described the Melissa intensification in terms that should resonate deeply with anyone thinking about the 2026 Gulf Coast. For a lot of the time when Melissa was just a tiny tropical storm, there were high winds, and it was just not able to get its act together. It was being pulled apart. Different convective parts were in all different places. But then eventually, when the wind shear calmed down, there was a couple-day window, and then it just took off. I need you to internalize that description, because it is a precise portrait of what a breakthrough storm looks like in a high shear environment. The shear is there. It is hostile. It suppresses the storm for days. The storm looks weak, ragged, disorganized. Every track model shows it dissipating, and then the shear fluctuates. A ridge shifts. An upper-level trough passes through. The hostile winds relax for 48 hours. And in that window, the storm finds warm water, and the feedback loop ignites like a match dropped in gasoline. That happened 4 times in 2025. 4 storms rapidly intensified in a season with only 13 named storms. The season produced the second most Category 5 hurricanes on record. Quality over quantity. The warm ocean selected for the strongest survivors and gave them the energy to become historic. And the detail that connects all of this to the 2026 forecast is something that I think most Americans have already processed and discarded. No hurricane made landfall in the United States in 2025. Not one. For the first time since 2015, the continental United States went an entire season without a hurricane landfall. The North Atlantic oscillation and a favorable atmospheric steering pattern directed most storms northward and eastward into the open Atlantic, away from the Gulf Coast and the eastern seaboard. NOAA Administrator Neil Jacobs, in his official season summary, called it a much-needed break. That phrasing is telling. It implies that the break was the exception, that the default state is hurricanes hitting the United States. That 2025 was a coin flip that came up heads. And that brings me to a point that I think is critical for understanding what is at stake in 2026. The United States has now experienced 2 consecutive years, 2024 and 2025, with back-to-back Category 5 hurricanes forming in the Atlantic Basin. 5 Category 5s in 2 years. Beryl and Milton in 2024. Erin, Humberto, and Melissa in 2025. That is the highest 2-year total since 1932 and 33. The storms are getting stronger. The intensification is getting faster. The ocean is warmer than it has ever been. And the United States has dodged every major hurricane landfall for an entire year. That is not evidence that the system works. It is evidence that the geometry was favorable. Jamaica was not so lucky. Melissa devastated the island. The Outer Banks took wave damage from Erin and Humberto. Bermuda was hit by Imelda. The storms were there. They were real. They were historically powerful. They just went somewhere else. There is no law of physics, no atmospheric constant, no ENSO correlation that guarantees the steering patterns will be favorable again in 2026. And if even one of those storms enters the Gulf of Mexico instead of curving out to sea, the outcome changes categorically, because the Gulf water that produced Milton at 180 miles per hour in 2024 is the same water, or warmer, that will be there in 2026. Part 8. The window before the wall. Now I need to bring the two timelines together, because this is where the convergence reveals the actual risk profile of the 2026 season. Timeline 1 is atmospheric. El Niño is developing in the Pacific. It is expected to emerge as a moderate to strong event during the summer, potentially reaching Super El Niño status by fall. The atmospheric effect will be increased vertical wind shear across the tropical Atlantic and Gulf, creating a hostile environment for tropical cyclone formation. This is the timeline that produces the below normal storm count. Timeline 2 is oceanic. The Gulf of Mexico is at record or near record sea surface temperatures for late May. Ocean heat content is near the highest levels ever measured. The loop current is in a regrowth phase. Deep, warm water is available to fuel rapid intensification. The Gulf has been warming at twice the global rate for 50 years and 16 times the historical rate during peak season since 2012. These timelines are not additive. They are in direct opposition. One reduces the number of storms, the other increases the destructive potential of every storm that forms. The seasonal forecasts resolve this tension by predicting the net outcome, which is below normal activity. But that resolution hides the mechanism of danger. Here is why. The Fox Weather Forecast Center conducted a historical analysis in April 2026 that I think should have been front-page news. They examined every tropical system that formed in the Gulf of Mexico during June through August across multiple El Niño years. The finding was clear. El Niño dramatically reduces the odds of Gulf tropical development during the summer, but there is a critical timing issue that most seasonal forecasts do not address. El Niño has not fully established yet. As of late May 2026, the Pacific is in ENSO neutral conditions. The transition to El Niño is expected, but the exact timing is uncertain. NOAA projects it will emerge within 1 to 3 months. If it develops quickly and is locked in by early July, the shear shield over the Gulf will be up during the hottest months. But if the transition is slow and El Niño does not fully take hold until late August or even September, there will be a window, a period of weeks, possibly a month or more, where Gulf sea surface temperatures are at their annual maximum. The loop current is providing deep heat, and the El Niño wind shear has not yet arrived. Meteorologist Alex Berggren highlighted this explicitly. He noted that 5 of the last comparable setups, years where a strong El Niño developed during the season rather than before it, produced 1 or 2 tropical systems that impacted the Gulf Coast, Florida, or the Southeast before the shear shield fully established. AccuWeather senior meteorologist Chad Merrill described this threat as homegrown development, storms that form close to the United States coastline within the Gulf itself, rather than crossing the Atlantic from Africa. Homegrown Gulf hurricanes are the most dangerous kind for 2 reasons. They give minimal lead time, sometimes as little as 48 to 72 hours from disorganized disturbance to major hurricane, and they form directly over the warmest water in the basin, giving them immediate access to the energy needed for rapid intensification. AccuWeather's lead hurricane expert, Alex da Silva, went further in his 2026 pre-season analysis. His team identified the northern and northeastern Gulf Coast, from just west of New Orleans, through the Florida Panhandle, and around to Tampa Bay, along with the Carolinas, as the regions facing the highest threat of direct impacts this season. That assessment was based on analog year analysis, comparing years with similar ENSO and SST configurations. The clustering pattern in those analog years showed a concentration of activity along the northern and eastern Gulf, which is precisely where the loop current's influence is strongest and where the continental shelf is shallowest, maximizing storm surge for any landfalling system. Da Silva warned specifically about rapid intensification, saying it was not a theoretical concern, but a measured trend. He pointed to the 2025 season as proof of concept. That year had a near-average number of storms, but produced 3 Category 5s, all of which rapidly intensified. Quality over quantity. It is important to understand that El Niño does not create an impenetrable barrier. The last time El Niño was present during an Atlantic hurricane season was 2023. That year produced 20 named storms, well above the average of 14, and included several that made landfall. 2023 demonstrated that El Niño can be overwhelmed by other factors, particularly record warm Atlantic sea surface temperatures. The ocean and the atmosphere were in a tug of war, and the ocean won. Now, the developing El Niño in 2026 is expected to be stronger than the one in 2023, which would provide more shear, but the Gulf's ocean heat content is also higher now than it was in 2023. The tug of war continues, and the rope is being pulled harder from both sides. The specific danger zone for the Gulf Coast is the early to mid-season, June through August, before El Niño has fully established its shear regime. Newsweek reported in May 2026 that meteorologist Mike Berggren warned that years with developing super El Niños have historically produced impactful tropical systems along the Gulf Coast and southeast in the early weeks of the season. 5 of the last comparable setups saw 1 or 2 systems hit before El Niño took full effect. And a homegrown Gulf storm in July 2026 would be forming over water that is already above the rapid intensification threshold, with the loop current providing deep heat and before the El Niño shear shield is online. That is the nightmare scenario for emergency managers. Not a storm that crosses the Atlantic and gives 5 or 6 days of warning. A storm that appears in the Gulf and becomes a major hurricane before most people realize it exists. Hurricane Michael in October 2018 is the textbook example of this threat. It went from a tropical depression on October 7th to a Category 5 hurricane making landfall at Mexico Beach, Florida on October 10th. 3 days, 160-mile-per-hour winds at the coast. Much of the intensification happened in the final 24 hours. The National Hurricane Center's track forecast was good, but the intensity forecast underestimated the storm's maximum winds by over 40 miles per hour, just 24 hours before landfall. The residents of Mexico Beach, who chose to shelter in place based on the Category 2 or 3 forecast, found themselves in a Category 5. Many did not survive. The seasonal forecast that year had called for near-normal activity, and it was near normal. 15 named storms, 8 hurricanes, 2 major, perfectly average by the numbers. But one of those 15 was Michael, and Michael was enough. And Melissa, in 2025, showed the same pattern in even starker terms. CSU research scientist Levi Silvers described what happened. For a lot of the time when Melissa was just a tiny tropical storm, there were high winds, and it was just not able to get its act together. It was being pulled apart, different convective parts in all different places. But then, eventually when the wind shear calmed down, there was a couple-day window, and then it just took off. A couple-day window. That is all it takes. The shear suppresses the storm for days, exactly as El Niño is supposed to do. The storm looks ragged, weak, harmless on the satellite imagery. Every model shows it struggling. Every forecast discussion mentions the hostile environment. And then the shear drops. For 48 hours, a ridge builds. The upper-level winds relax. The storm finds the loop current. And in that window, the feedback loop ignites. And the transformation from nuisance to catastrophe takes less time than a long weekend. The seasonal forecasts project average conditions over the entire 6-month season. They cannot project the individual 2-day windows where shear temporarily relaxes. And those windows happen in every El Niño year, without exception. The shear field is not a solid wall. It pulsates. It has gaps. It is modulated by mid-latitude weather patterns that operate on timescales of days, not months, and that no seasonal model can predict 5 months in advance. All it takes is one gap over the Gulf, at a time when a disturbance is sitting over record warm water, and the season changes character in less time than most people can pack an evacuation vehicle. Part 9. 50 million people in the path. I want to shift the lens now from the atmosphere and the ocean to the land, because the vulnerability equation has been changing just as fast as the thermodynamic equation, and in the same direction. A study published in April 2026 in the journal Science Advances, led by researchers at the University of Alabama, found that more than 17 million people along the US Atlantic and Gulf coasts are at the 2 highest risk levels for flooding from tropical cyclones. 17 million people. The study used 16 different vulnerability factors, including geographic hazard exposure, population density, infrastructure condition, and socioeconomic characteristics that affect evacuation capacity and recovery speed. Census Bureau data shows approximately 60 million Americans live in coastline counties along the Atlantic and Gulf, the areas most susceptible to hurricane impacts. The Gulf Coast specifically has been the fastest growing coastal region in the country. Between 2000 and 2017, Gulf Coast counties added more than 3 million people, a 26.1% population increase. The national rate over the same period was 15.7%. The Gulf Coast is growing at nearly double the national pace, and it is growing into the path of hurricanes. Nearly 40% of the entire US population now lives in a coastal county, and the Gulf Coast counties are disproportionately home to what disaster researchers call socially vulnerable populations. Higher poverty rates, older and less resilient housing stock, fewer transportation options for evacuation, less financial capacity for recovery. In Harris County, Texas, home to Houston and nearly 5 million people, more than 1/5 of the population is classified as socially vulnerable. In New Orleans, 380,000 people are at the highest flood risk levels, which represents 99% of the city's population. And here is the compounding factor that almost never appears in hurricane season forecasts. Modern coastal cities are not just exposed to storm surge and wind, they are exposed to cascading infrastructure failures that amplify the impact of any hurricane beyond what the meteorological data alone would predict. When Hurricane Beryl hit Texas in July 2024, 3 million homes and businesses lost power. 3 million. The outage lasted several days, coinciding with extreme summer heat. Losing electricity in Houston when temperatures exceed 100 degrees is not an inconvenience. It is a medical emergency, particularly for elderly residents people with chronic health conditions, and families with young children who depend on air conditioning for survival. The power grid along the Gulf Coast has not been upgraded to withstand Category 4 or 5 hurricane winds. The levee systems protecting New Orleans and other low-lying communities, while improved since Katrina, are designed to a specific standard that could be exceeded by a storm that undergoes unexpected rapid intensification. The evacuation corridors for major Gulf cities require 12 to 36 hours of lead time to clear, and in a homegrown rapid intensification scenario, that timeline may not be available. So when the seasonal forecast says below normal, I need you to understand what that phrase covers and what it does not. It covers the expected number of storms across the entire basin. It does not cover the number of people at risk. It does not cover the thermal energy available to any storm that forms. It does not cover the infrastructure vulnerabilities that have accumulated over decades of coastal development. And it does not cover the behavioral response that the phrase below normal triggers in the population. Part 11. The geography of no escape. I want to spend some time on the physical geography of the Gulf Coast, because it is essential to understanding why the Gulf is not just another ocean basin, and why a single rapidly intensifying hurricane in the Gulf is categorically different from the same storm in the open Atlantic. The Gulf of Mexico is a semi-enclosed basin. It is bounded by the United States to the north and east, Mexico to the west and south, and Cuba to the southeast. The Yucatan Channel and the Straits of Florida are the only significant openings to the broader Atlantic. This enclosed geometry has two consequences that are directly relevant to hurricane risk. First, it limits the water's ability to disperse heat. In the open Atlantic, warm surface waters can spread laterally over thousands of miles. In the Gulf, they are trapped. The heat accumulates in a confined space, and as the loop current continuously pumps warm Caribbean water through the Yucatan Channel, the Gulf becomes a thermal pressure cooker. The heat has nowhere to go except up into the atmosphere, where it becomes fuel for any convective system that passes overhead. Second, and more importantly for the people living along the coast, the northern Gulf shoreline is extraordinarily low-lying and shallow. The continental shelf along the Gulf Coast extends outward for miles before reaching deep water. This shallow bathymetry is what makes Gulf hurricanes disproportionately deadly when it comes to storm surge. Storm surge is the mound of ocean water pushed ahead of a hurricane by its winds. In deep water, this mound dissipates, but when it reaches a shallow continental shelf, the water has nowhere to go but up. The shallower the water, the higher the surge piles. Along the northern Gulf Coast, from Texas through Louisiana and Mississippi to the Florida Panhandle, the continental shelf is broad and gentle. This is why the Gulf produces the most extreme storm surges in the Atlantic Basin. Hurricane Katrina's surge reached 28 feet along the Mississippi coast. That is a 3-story wall of ocean water moving inland at speed. It reached 12 miles inland in some areas, and the storm was a Category 3 at landfall, not a Category 5. If Katrina had maintained its Category 5 intensity to shore, the surge models indicated potential values exceeding 35 feet. Now think about what rapid intensification means in the context of storm surge forecasting. The National Hurricane Center issues storm surge watches and warnings based on the forecast track and intensity of a hurricane. If a storm is projected to make landfall as a Category 2, the surge forecast might call for 6 to 9 feet. But if that same storm undergoes rapid intensification in the final 18 hours and arrives as a Category 4, the actual surge could be 15 to 20 feet. The surge watch was based on the wrong storm. This is not hypothetical. Hurricane Michael, in 2018, was forecast to make landfall as a Category 2 or 3. It rapidly intensified to Category 5 in the final hours, and the storm surge at Mexico Beach reached 14 feet, well above the initial projections. Entire neighborhoods were erased. The concrete block homes were reduced to foundation slabs. And this was a relatively compact storm. A larger system with the same intensity would have produced even greater devastation. Along the Gulf Coast, the population centers most at risk from this scenario form a nearly continuous chain. Houston, the Texas coastal bend, New Orleans, Gulfport, Biloxi, Mobile, Pensacola, Panama City, Tampa Bay, Fort Myers, Naples. These are not small towns. These are metropolitan areas with combined populations in the tens of millions, connected by evacuation routes that were designed for a fraction of the current population. Part 12. The evacuation that cannot happen fast enough. Let me walk you through the mathematics of evacuation, because this is where the rapid intensification threat intersects with the population growth in a way that is genuinely alarming. The standard evacuation timeline for a major Gulf Coast city, from the issuance of a mandatory evacuation order to the clearing of the last residents from the surge zone, runs between 24 and 72 hours, depending on the size of the metro area and the capacity of the road network. Houston's evacuation plan, revised extensively after the Rita evacuation disaster in 2005, calls for a phased, zone-by-zone approach that requires approximately 36 to 48 hours of lead time. New Orleans requires a minimum of 72 hours because of the geography, the limited number of evacuation routes, and the large population without private transportation. Tampa Bay, which has not taken a direct hit from a major hurricane in over a century, has one of the most precarious evacuation profiles in the country. The bay is surrounded by low-lying communities on a peninsula. The primary evacuation routes funnel through a small number of bridges and highway corridors. Traffic modeling by the Tampa Bay Regional Planning Council suggests that a full-scale evacuation of surge-vulnerable zones could take 48 to 72 hours, and that is assuming compliance rates above 80%. Now consider the rapid intensification scenario. A tropical disturbance organizes in the Central Gulf on a Monday morning. By Monday evening, it is a named tropical storm. By Tuesday morning, it has found the loop current. By Tuesday afternoon, it is rapidly intensifying. By Wednesday morning, it is a Category 4 with sustained winds of 140 miles per hour, aimed at a major metropolitan area. Total time from disorganized disturbance to Category 4 landfall threat, roughly 60 hours. Subtract the time needed for the National Hurricane Center to issue watches and warnings, which typically requires the storm to be at least 36 hours from landfall as a tropical storm or 48 hours for hurricane conditions. Subtract the time for local emergency management to process those warnings, brief elected officials, coordinate with state and federal agencies, and issue evacuation orders. Subtract the time for media to disseminate the message and for the public to respond. By the time a mandatory evacuation order reaches the average resident's phone, the window for safe departure may already be closing. And if the forecast was for a below normal season, the psychological readiness of the population is lower. People hesitate. They wait for the next update. They wait for their neighbors to leave first. They wait until the sky darkens and the rain begins, by which point the evacuation corridors are saturated and the option to leave has effectively expired. This is not a failure of emergency management. It is a failure of physics. The Gulf is too warm. The intensification is too fast. The coastline is too populated. And the lead times that the current warning system provides are based on historical intensification rates that may no longer apply in an ocean that is warming at 16 times the long-term trend. Part 13. The insurance crisis nobody mentions in the forecast. There is another dimension to the Gulf Coast vulnerability that the seasonal outlook does not address, and I want to put it on the table because it fundamentally changes the recovery equation. The property insurance market along the Gulf Coast is in crisis. Insurers have been pulling out of coastal markets for several years, driven by the escalating frequency and cost of hurricane claims. In Florida, the property insurance market has seen multiple carriers exit or go insolvent since 2020. Citizens Property Insurance, the state-run insurer of last resort, has become one of the largest property insurers in the state, covering millions of policies that the private market refused to write. In Louisiana, the same pattern has unfolded. After Hurricanes Laura, Delta, and Zeta in 2020, and Hurricane Ida in 2021, multiple insurers left the state. Premiums for those who can still get coverage have increased by 50 to 200% in some coastal parishes. Deductibles have risen. Coverage limits have tightened. What this means in practice is that the financial resilience of coastal communities to a major hurricane has deteriorated even as the physical threat has intensified. A storm that might have caused $50 billion in insured losses a decade ago could now result in a significantly larger gap between total damage and insured coverage. Homeowners who cannot afford the new premiums go without coverage. Homeowners who have coverage may find that their deductibles are so high that the first $20,000 or $30,000 of damage comes out of pocket. The National Flood Insurance Program, which provides the vast majority of flood coverage in the United States, has been in precarious financial condition for years. The program owes the U.S. Treasury more than $20 billion in outstanding loans from previous major hurricane seasons. And flood insurance is separate from wind insurance, meaning that a homeowner needs both to be fully protected, and many have neither. This is the hidden multiplier in the 2026 risk equation. The physical danger is higher than ever. The population is larger than ever. The infrastructure is more vulnerable than ever, and the financial safety net that is supposed to catch people after the storm has been fraying for years. A below-normal season does nothing to address any of these structural vulnerabilities. They will be there regardless of how many storms form. And if one storm finds the Gulf Coast, the recovery will be slower, more painful, and more unevenly distributed than at any point in modern American disaster history. And that brings us to the convergence that I believe defines the real danger of the 2026 hurricane season. Because below normal in the public mind translates to one thing: this year is safer. And when 50 million people believe they are safer, they make different decisions. They defer hurricane shutter maintenance. They skip the restocking of emergency supplies. They let flood insurance policies lapse. They plan August beach vacations without checking tropical weather. They choose not to evacuate when the first warnings come because they have internalized the narrative that this is a quiet year. And that behavioral shift is not a side effect of the forecast, it is a direct consequence, one that the historical record shows is correlated with higher casualty rates, the word that kills. Below normal, let me tell you what those two words did in 1992. Through mid-August of that year, the absence of tropical activity had become the story. News coverage focused on the quiet season. Preparedness dropped. Public attention drifted. And on August 16th, the very day the NHC was publicly discussing the lack of activity, a tropical wave that would become Andrew was already crossing the central Atlantic. Andrew gave South Florida roughly 4 days of warning from the time it became a named storm to landfall. 4 days should be enough. It usually is. But the 4 days came after 3.5 months of public messaging that the season was inactive. The urgency was diminished. The compliance with evacuation orders was lower than it should have been. And when Andrew hit Homestead at 165 miles per hour, the community was less prepared than it would have been in a year when the public was primed to expect danger. 63,000 homes destroyed, 100,000 damaged, 65 dead, $27.3 billion. The word below normal did not cause Hurricane Andrew, but it shaped the context in which Andrew was received, and that context cost lives. Now apply that same dynamic to the 2026 Gulf Coast, a population that has grown by 26% since 2000. Infrastructure that has not kept pace. A thermal ocean environment that is dramatically more energized than 1992. And a public that has just been told by the most trusted name in weather forecasting that this year will likely be below normal. The most dangerous hurricane season is not the one with the most storms. It is the one where the public does not expect a storm and gets one anyway. Part 11, the number that should not exist. I have been holding one more data point, and I want to put it on the table now because I think it crystallizes the problem better than anything else in this debrief. From 2012 to 2025, 11 of the 29 hurricanes observed in the Gulf of Mexico underwent rapid intensification. That is 38%. More than 1 in 3 Gulf hurricanes rapidly intensified before making landfall or shortly after entering the Gulf. During the previous 14-year period, 1998 through 2011, which includes the historically extreme 2005 season with Katrina, Rita, and Wilma, 14 of 27 Gulf hurricanes underwent rapid intensification. 52%, the total fraction of rapidly intensifying Gulf hurricanes, has not spiked beyond historical norms yet. But the base conditions have changed radically. The ocean is warmer. The deep heat content is higher. The loop current eddies are providing more concentrated reservoirs of energy. And the peer-reviewed literature says rapid intensification is 50% more likely during marine heat waves, with hotspots in the Gulf showing probability increases of up to 500%. What this means is that the baseline probability of any given Gulf hurricane rapidly intensifying before landfall is now structurally higher than at any point in the observational record. And rapid intensification is the scenario that breaks the emergency management system. It compresses the decision window from days to hours. It turns a Category 1 evacuation into a Category 4 shelter in place faster than the warning infrastructure can communicate the change. Research on the intensity-temperature relationship tells us that potential intensity rises 5 to 7% for each 1 degree Celsius of warming. The Gulf has warmed by about 0.5 degree Celsius per decade during peak seasons since 2012. That is already adding roughly 3% per decade to the peak winds in the strongest storms. And because wind damage scales with the cube of wind speed, a 3% increase in wind speed translates to a roughly 9% increase in destructive potential. These numbers do not appear in the seasonal outlook. They live in the research literature, in the observation records, in the data that Brian McNoldy and Kim Wood and Jeff Masters publish regularly. And they paint a picture that the seasonal storm count simply cannot capture. Part 15. 2 trains, 1 crossing. So let me now synthesize everything we have covered, because this is the convergence that I believe defines the real danger of the 2026 hurricane season. You have an atmospheric timeline that says fewer storms. El Niño is developing. Wind shear will increase. The Atlantic hostile environment will suppress tropical cyclone genesis, especially in the main development region off the coast of Africa. The the total number of named storms will likely be below the 30-year average. This is real. This is supported by decades of research and by some of the most robust statistical relationships in all of climate science. And you have an oceanic timeline that says more dangerous storms. Gulf sea surface temperatures are at or near records for late May. Ocean heat content is at or near the highest levels ever measured. The loop current is in a regrowth phase, extending northward into the central Gulf, positioned to provide deep, warm water to any storm that crosses its path. A possible regime shift since 2016 has elevated the Gulf's thermal baseline by a factor of 4 compared to the previous decade. The conditions for rapid intensification are in place now, in May, and will only intensify through September. This is also real. This is also supported by observational data and peer-reviewed research. These two timelines are running toward the same 6-month window, June 1st through November 30th, aimed at the same coastline where 60 million Americans live and work and raise their families. Think of it as two trains approaching the same crossing from different directions. One train carries the suppressive atmospheric effects of El Niño. The other carries the energetic oceanic potential of record-warm Gulf waters. The seasonal forecasts are essentially betting that the atmospheric train arrives first and blocks the crossing. And in most El Niño years, that bet pays off. But the oceanic train has been accelerating for over a decade. The Gulf warming trend is not linear. It is not even steadily increasing. It is accelerating. The rate of warming during peak season has increased 16-fold since 2012. And the atmospheric train, El Niño, has not even departed yet. It is sitting in the station as ENSO neutral conditions, expected to develop sometime in the next 1 to 3 months. Timing uncertain. The exact date when the wind shear shield will be fully operational over the Gulf is unknown. If the atmospheric train arrives early and strong, July, maybe, the Gulf will likely be sheared and hostile through peak season. The crossing will be blocked. The below normal forecast will verify. And 50 million Americans will have dodged the bullet again. But if El Niño develops late, if the transition from neutral to moderate is gradual, if the wind shear does not fully establish until late August or September, there will be a window, weeks, possibly a month or more, where the Gulf is at its hottest. The loop current is providing maximum deep energy, and the atmospheric conditions have not yet shifted to the hostile regime. The crossing will be open, and the oceanic train, loaded with more thermal fuel than at any point since the beginning of the instrumental record, will have a clear, unobstructed path to the coast. Part 16. The scenario nobody wants to model. I want to walk you through what the worst-case 2026 scenario actually looks like. Not because I think it is the most probable outcome, but because it lives within the probability space that the seasonal forecasts allow. And because I think every person living in a Gulf Coast evacuation zone deserves to understand what the data says is possible. It is late July. El Niño has been slow to develop. The Pacific warm anomaly is present, but has not yet translated into full atmospheric disruption over the Atlantic. Wind shear in the Gulf is intermittent, not persistent. Gulf sea surface temperatures have reached 87 degrees Fahrenheit, 3 degrees above the threshold for sustaining Category 4 and 5 hurricanes. The loop current has extended well into the central Gulf and is about to shed another warm core eddy. A tropical wave exits the African coast and crosses the Atlantic. The shear tears it apart, but a residual vortex survives and drifts into the Western Caribbean. It encounters a temporary break in the shear, a 2-day window created by a passing mid-latitude trough. The circulation tightens, convection flares, Within 36 hours, it becomes a tropical storm. It enters the Gulf through the Yucatan Channel, passes directly over the loop current, and begins feeding on 100 meters of 85-degree water. The shear in the Gulf is light. The environment is permissive. The feedback loop ignites. In 12 hours, it is a hurricane. In 24 hours, it is a major hurricane. In 36 hours, it is Category 5. The entire transition from disorganized tropical remnant to 160-mile-per-hour hurricane happens in 3 days. The storm is aimed at the Louisiana or Upper Texas coast, or Tampa Bay, or the Florida Panhandle. Mandatory evacuation orders are issued 48 hours before projected landfall. But the storm was only a tropical storm 48 hours ago. The public saw a disorganized mess on the satellite imagery yesterday morning. The news was covering the quiet hurricane season. The evacuations start late. The roads are congested with vacationers. The shelters are understaffed because the budget assumed a below normal year. The storm makes landfall with 20-foot storm surge, Category 4 winds, and catastrophic rainfall that extends 300 miles inland. Infrastructure fails in cascade. The power grid collapses. The levees hold, but barely. The flooding in low-lying neighborhoods exceeds the capacity of the pump systems. Cell service goes down. First responders cannot reach stranded residents for 48 to 72 hours. And then the secondary effects begin. Without power, water treatment plants shut down. Boil water advisories are issued across the metro area. But the advisory is meaningless to people who have no power to boil water and no cell service to receive the advisory. Hospitals switch to generator power, but generators run on diesel, and the diesel supply chain is disrupted because the ports are closed and the roads are flooded. Nursing homes, which were supposed to evacuate but could not arrange transport in time, are now isolated with residents who depend on electricity-powered medical equipment. The temperature outside is 95 degrees. Inside, without air conditioning, it is higher. Heat-related casualties begin within 24 hours. Mold begins growing in flooded structures within 48 hours. The chemical plants and refineries along the Gulf Coast, which contain millions of gallons of hazardous materials, have lost power to their containment and safety systems. Some release toxic fumes. Some catch fire. The Superfund sites that line the coast from Texas to Mississippi, over 30 of them in the Houston Ship Channel alone, begin leaching contaminants into the floodwaters. This cascading failure is not speculation. This is what happened during Harvey. This is what happened during Katrina. This is what happened during Ida. Each time, the secondary effects killed more people and caused more economic damage than the primary event. And each time, the coastal infrastructure was less resilient than the public had been led to believe. I want to be absolutely clear. This scenario is not a prediction. It is a possibility. One that the laws of physics and the current state of the Gulf of Mexico fully support, and the seasonal forecast that says below normal does not exclude it. It allows for 1 to 3 major hurricanes, and this would be one. The probability of this specific scenario may be low, but the consequences are so severe that even a low probability demands preparation. And that is the fundamental disconnect between what the forecast communicates and what the risk actually is. A 5% chance of a $150 billion catastrophe is not a small risk. It is an enormous risk. If you would not board a plane with a 5% chance of crashing, you should not live on the Gulf Coast without a hurricane plan and active insurance, because a seasonal forecast told you the season would be below normal. The question that nobody in the seasonal forecasting community can answer is whether this scenario will find the 2-day window of relaxed shear that it needs. And the honest answer is that nobody knows. Because the shear environment fluctuates on timescales of days, not months, and seasonal forecasts operate on month-to-month averages. Part 17. What the models cannot see. I want to spend a moment on the forecasting models themselves, because I think there is a structural gap between what the models predict and what the public hears. And that gap is part of the danger. Seasonal hurricane forecasts are statistical tools. They are based on large-scale climate indices, primarily ENSO state, Atlantic sea surface temperatures, African easterly wave activity, and atmospheric circulation patterns. They are good at predicting the total number of named storms across the entire Atlantic basin over a 6-month period. They have demonstrated measurable skill at this task over the past 3 decades. But they are not designed to predict individual storms. They cannot tell you when a specific hurricane will form, where it will go, how strong it will be, or whether it will make landfall. They are basin-wide seasonal averages, not weather forecasts. The gap between the seasonal forecast and the actual danger to any individual city on the Gulf Coast is enormous. A seasonal forecast that predicts 8 named storms basin-wide is fully consistent with one of those 8 storms being a Category 5 that hits Houston, or New Orleans, or Tampa. The forecast says 8. It does not say where those 8 will go, or what they will do when they get there. And the models cannot predict rapid intensification on seasonal timescales. They cannot forecast the 2-day shear windows. They cannot anticipate the exact position of the loop current eddies in August or September. They cannot model the interaction between a specific tropical cyclone and a specific patch of deep warm water that happens to be in its path. These are the factors that determine whether a season is remembered as quiet or catastrophic, and they are invisible to the seasonal outlook. NOAA says this explicitly. The outlook is not a landfall forecast, but the public does not read the fine print. The public reads below normal and translates it into safe. And the distance between below normal and safe, measured in Gulf sea surface temperature, in loop current depth, in coastal population density, in insurance market instability, in evacuation corridor capacity, is the distance between a statistic and a catastrophe. Part 18. The forecast that matters. NOAA Administrator Neil Jacobs said the most important sentence in the entire 2026 outlook, and I want to close by returning to it, because I think it contains the actual forecast for the people who live along the Gulf Coast. Even though we are expecting a below-average season in the Atlantic, it is very important to understand that it only takes one storm, not one season, not 1 month, not 1 week, one storm, one tropical disturbance that organizes in the Bay of Campeche or the Western Caribbean during a 2-day window of relaxed shear. One circulation that drifts over the loop current with 100 meters of 84-degree water below it. One feedback loop that runs unchecked for 24 hours while the atmospheric brakes are temporarily off. 180-mile-per-hour winds at the coast with 36 hours of warning. That is not the below-normal scenario, but it is a scenario that is fully consistent with below-normal total activity. Andrew happened in a below-normal year. Alicia happened in a below-normal year. Michael happened in a near-normal year and was a homegrown Gulf storm that went from tropical depression to Category 5 in 3 days. And Melissa happened in a near-normal year and became the strongest Atlantic hurricane landfall in recorded history. The seasonal count is a number that describes the entire Atlantic basin over 6 months. The danger to any individual city on the Gulf Coast is described by the temperature of the water beneath it, the depth of that heat, the behavior of the loop current, the timing of El Niño's arrival, the insurance coverage of the population, the capacity of the evacuation routes, the integrity of the power grid, and the 2-day windows of opportunity that exist in every wind shear regime in every hurricane season ever recorded. All of those factors, right now in late May 2026, point in the same direction. Fewer storms, but the ones that form will have access to more energy over a more populated and more financially vulnerable coastline, with less warning time and less margin for error than at virtually any previous point in the observational record. Part 19. When everyone stops watching. I opened this debrief with a number, 55%, the probability NOAA assigned to a below normal season. And I want to close by reframing that number one final time. If there is a 55% chance the season is below normal, there is a 45% chance it is not. There is a 35% chance it is near normal. A near normal season includes 7 hurricanes and 3 major hurricanes. There is a 10% chance it is above normal. An above normal season can include the kind of hyperactive stretch that produced Katrina, Rita, and Wilma in a span of 8 weeks in 2005. Even the below normal scenario, the most likely outcome, allows for up to 3 major hurricanes, Category 3 or higher, sustained winds exceeding 111 miles per hour, storm surge that rewrites shorelines, rainfall that overwhelms drainage systems designed for a different climate. None of these probability ranges includes the word safe. The most dangerous moment in any hurricane season is the moment the public decides the season is over. When August passes without a US landfall and the cable news moves on, when the storm tracker apps get deleted, when the plywood comes down from the windows and gets stacked in the garage, when the flood insurance renewal notice goes into the recycling bin because the season has been so quiet that it seems like a waste of money. That is the moment of maximum vulnerability. Not because the storms have stopped, but because the attention has. Hurricane Andrew formed on August 16th, after the National Hurricane Center publicly discussed the lack of a season. Milton formed on October 5th, when most of Florida was focused on post-Helene recovery and not expecting another major Gulf threat so quickly. Melissa made landfall on October 28th, in the waning weeks of a season that many had already mentally closed. The Atlantic hurricane season is 6 months long. It has 2 statistical peaks, one in mid-September, one in mid-October. The most destructive storms in the historical record have often arrived after the public has already made its judgment about the season, after the guard has dropped, after the attention has shifted. On May 21st, 2026, NOAA gave America a number, 8 to 14 storms. Below normal and across the Gulf Coast, 50 million Americans heard that number and exhaled, but the Gulf of Mexico tied its all-time sea surface temperature record for mid-May, and the water is still warming. The loop current is extending northward into the central Gulf, building a corridor of deep heat directly in the path of any storm that enters from the Caribbean. Ocean heat content is approaching the highest values ever measured for this time of year, with 3 months of additional warming ahead before peak season. 5 Category 5 hurricanes have formed in the Atlantic in the last 2 years, each one powered by the same warm waters that are present in the Gulf right now. Rapid intensification is 50% more likely during marine heat waves. And the Gulf is in one. The Gulf Coast population has grown by more than 3 million people since 2000. The property insurance market is in crisis. The evacuation routes were designed for a population that no longer exists at this size. And in 1992, a season with only 7 named storms and a strong El Niño produced a single hurricane that destroyed 63,000 homes and killed 65 people in an era when the Gulf was cooler, the population was smaller, and the ocean had not yet begun its current acceleration. Below normal is not below dangerous. It never has been. The most dangerous moment is when everyone stops watching. And right now, I can tell you with precision that the instruments are still running. The satellites are still tracking. The Argo floats are still measuring the heat content at depth. The tilt meters on the loop current buoys are still registering the flow of warm Caribbean water into the Gulf. The data is still coming in. The ocean is still warming. And the season has not even started yet. The question is not how many storms will form this year. The question is whether the one that matters will find its window. And the Gulf of Mexico, patient and hot and waiting, does not care about seasonal forecasts. This is your nightly debrief. I will see you tomorrow night.